This is Sai Girish Surdevra, and today we are going to deep dive into football player potential analysis. In today's agenda, we are going to learn about the introduction to the topic, the problem statement and motive of the analysis, the dataset and tools which I have used to create this model, hypothesis and the results of this model, the conclusion, and how this work can expand into the future. The football players dataset provides a rich source of information on various aspects of player performance, potential, and characteristics, like comprehensive player attribute information, investigating correlations between player characteristics, understanding factors influencing player performance, football's intricate dynamics, demand detailed analysis, and utilizing data to comprehend player attributes impact. The main problem of this analysis is investigating correlations between age, preferred foot body shape, and player attributes, and understanding how these factors influence player potential, skill moves, and overall performance. Leveraging data analysis to gain insights for player recruitment, team formation, and game strategy, enhancing an understanding of football dynamics for coaches, scouts, and fans. For this model, I have used datasets like football player dataset from Kaggle, and I have used tools like Python to code with Pandas, Matplotlib. Seaborn Libraries is used for analyzing player statistics on Google Colab. Google Colab simplifies data science and machine learning with pre-installed libraries like NumPy, Pandas, Matplotlib, and TensorFlow, enabling seamless collaboration for project group. Google Colab offers free access to GPUs and TPUs, accelerating machine learning computations. It's a cloud-based platform, eliminates the need to use user computer setup, enabling code execution on powerful servers without hardware constraints. Coming to the exploratory data analysis, the first part is data cleaning. Data cleaning is an important part of the data analysis process that involves detecting and rectifying inaccuracies, inconsistencies, and missing items in the dataset to guarantee its credibility and dependability. Here's one way to get about tidying up the football players dataset. This piece of code handles missing values as well as cleanses the dataset. The absence of value underscore euro, wage underscore euro, and release underscore clause underscore euro are features with missing in the dataset. These missing values are replaced by median value per respective column, and those columns which have many missing values such as national team, national rating, national team position, and national jersey number will then be removed by drop function. After handling the missing data and deleting columns, it checks if there are any more missing data on our dataset. Finally, a clean version of this dataset gets saved to a new data frame called clean FIFA data using the copy method. This is the data summary of the complete dataset. The provided code snippet makes use of the describe function to compute summary statistics for both numerical and categorical columns in the clean dataset. This summary shows count, mean, standard deviation, minimum, maximum, and quartiles for numerical columns and count unique values, top frequency, and frequency of top value for categorical columns. Such descriptive analysis reveals central tendency, variability, and categorical distribution in the dataset, thereby helping us understanding its main features of recurring patterns that it might have. Coming to the hypothesis we derive from the dataset, there are main three hypotheses. The first hypothesis is age versus potential. The main hypothesis is of this age versus potential is younger players might likely have higher potential ratings compared to the aging ones. According to this hypothesis, younger athletes who are still growing may therefore possess a better chance of improvement and hence higher potential ratings than aging sportsmen who are unlikely to improve further. This is an idea which can be used to determine whether there exists a link between age as well as prospective assessments and how it varies across different ages. The second hypothesis is preferred foot and skill moves. This hypothesis describes players who prefer to use their stronger foot may have higher skill moves ratings. It is believed that players who predominantly favor one foot will also have greater dexterity and technique in other, hence it results to raised figures in skill moves. If we can establish the link between preferred foot and skill moves rating, then we can know whether it has any correlation and how it affects the player's capability. The third hypothesis is body shape and physical features. Specific physical attributes are best demonstrated by athletics of certain body shapes. This implies that diverse physical appearances such as skinny or fat may relate to physical attributes like height, weight, and strength. For instance, taller player may excel in aerial duels while the thinner ones may have greater pace values. As a result, establishing if there exists a special body shape relations between certain bodily characteristics of a game can possibly be given via the given examination. The following line graph shows the difference between age versus potential. A line graph is used as a data visualization which shows the average potential rating by age. This kind of visual works well in exhibiting the connection between two quantitative variables, in this instance age and potential rating. This line graph shows how potential ratings change with time, thus helping to address the hypothesis that younger players have higher potential ratings than their aging counterparts. The graph demonstrates that as its youngest point, presumably around 20 years old, the average potential rating is quite high, about 75, and gradually decreases as age increases, but not in a straight line. Thus, this downplaying trend supports young players having much better promising futures when compared to the old players. The line chart is apt because it allows visualization of continuous relationship between age and potential rating. The x-axis represents age while the y-axis represents the potential rating. It is one of the major style using 2D as a way of illustrating the relationship between two variables. For spatial arrangement, it has clear age of on x-axis and potential rating on y-axis, thereby following conventional presentation of data. This makes the visualization easy to follow through and understand since it only uses blue color in representing both line and dots that make up the data points. This scatter plot also helps us to find the differences between age and the potential of a player. The visualization under discussion is in the form of a scatter plot. This one way to display the relationship between two quantitative variables, namely potential and age. The data are represented by points in this graph. The hypothesis is that the younger players have higher potential ratings than older ones is supported by the scatter plot. We see a general trend where for younger players, the data points are more concentrated in the range of higher potential rating and then spread away gradually as we move down towards the lower rates of potential rating with age. Despite this, there is also a wide overlap in the rates of potential rating across different age groups. The 2D space design provides a standard and efficient means of illustrating the relationship between two variables. The arrangement in space has age as it moves along the y-axis to reach the potential rating. Using two different blues for dots assists in segregating observations from each other as well as creating depth perception in visualization. Avoiding any other visual elements enables undisturbed focus on data points themselves. The both line chart and scatter plot together confirm the hypothesis that suggests there is a greater possibility for younger players to have better potential ratings than older ones, as shown by the former, along with other data points recorded in the latter. Nevertheless, this diagram also shows huge inconsistencies among clusters that implies it's not just enough to consider someone's age. Through these images, we get adequate insight of the general design and realities behind the place and age of a scale potential rating. The next hypothesis is preferred foot and skill moves. Players who prefer to use their stronger foot may have higher skill move rating. The histogram explains the relationship between a player's skill move rating and which foot they prefer to use. This is what it has to say about the hypothesis. Skill moves rating of 1 to 5 is represented with x-axis. Higher values show better skill moves. On the y-axis, the number of frequency of players in each skill level for all levels are indicated. Bars are color-coded with orange ones representing players who prefer the right foot and blue ones representing the players who prefer the left foot. For lower skill move ratings, there are significantly more blue bars, showing that a greater proportion of them have better skills. The blue bars were taller at higher skill move ratings, reflecting that many of them had good skills in this range. This model seems to affirm or claim the players who have preference for their stronger foot do have higher skill move ratings. Histogram turned out to be the best visualization format since it gives effective way of showing the distribution variable across different categories. Histograms are good at visualizing and comparing frequency distributions. The structure is that bars for every rating of skill moves are side by side with orange bars for right-footed players and adjacent to blue bars left-footed players. These groups can be easily compared all the way through the level of skill move ratings. Next comes the box plot, which also is used for the depicting hypothesis 2, that is preferred foot and skill moves. Dominant food group has a higher median. Dominant food group has a large range between the first quartile and third quartile. Outliers of dominant food group are above average. This means that if these patterns are seen, it will imply that the hypothesis has been true. Nevertheless, this may need further statistical analysis to draw solid conclusions. Boxplot was chosen as the appropriate visualization format since it effectively summarizes and displays the distribution of a quantitative across various categories. They represent important statistical measures such as median, interquartile range, and outliers in a concise manner which makes them suitable for comparing distribution. The y-axis has skill moves rating while x-axis has preferred food groups. This design enables easy comparisons between the two groups along the horizontal x-axis. Both box plots use blue color for skill move ratings for both preferred food cases. The choice of these colors is neutral, so it does not bring any form of bias or detract from what one should be primarily focused on comparing the distributions. In conclusion, the design choices for both box plot and histogram were meticulously crafted to effectively communicate distribution of skill moves ratings and relationship between preferred foot and skill moves rating respectively. By leveraging basic perceptual tasks using 2D space, arranging spatial layout, and using an appropriate color scheme, these visualizations facilitate simple comparisons, analysis of central tendencies spread in data, as well as understanding how our preferred feet relate closely with our ability to execute certain moves on football fields. The third hypothesis is body shape and physical features. Specific physical attributes are best demonstrated by athletics of certain body shapes. It is suitable to use a bar chart when displaying the comparing average height across different categories like body types. This will accurately represent the quantitative measures of height in this form of visualization. It is suitable to use a bar chart when displaying and comparing the average height across different categories like body types. Body types are on x-axis, while in on y-axis for two-dimensional space. Since every category is directly translated into its corresponding tallies, it promotes easier understanding and comparisons. The bar appears horizontal next to one another, with each representing a different body type. Such positioning enables effective visual comparison of all heights among all types within one plot area. All bars are colored blue throughout, which makes them look neutral. Single colors aiming at minimizing any possible bias or distraction from the main goal that entails the comparing average height across various body types. The next is the bubble graph, which also depicts the body shape and physical features. A bubble plot represents an elementary perceptual task for comparing positions and patterns. Each point indicates a single player and their positions relative to one another, as well as along weight strength axis can be observed visually for any potential relationships or trends. Therefore, a bubble plot would be appropriate when illustrating relationships between two quantitative variables such as weight and strength within different categories such as body types. The two-dimensional space has weight on the x-axis and strength on the y-axis. This configuration allows representation of both variables simultaneously, hence the compatibility of the relationship analysis. Data points are scattered all over with their position determined by respective weight and strength value. This arrangement shows how each player varies in terms of weight and strength for a given combination of the two variables. Different colors can be used to represent different body types, which would make it easier to identify patterns or clusters within the group. In summary, both charts effectively address the hypothesis by providing opportunities to examine possible correlations between physical attributes with body types. The bar chart compares average heights across body types, while scatter plot provides insights on the relationship between weight and strength among different body types. Overall, the football player's data analysis has provided important insights on how various attributes and features of a player are interconnected. This includes hypothesis-driven analysis as well as visualization techniques to see how age, preferred leg, skill moves, physical attributes, player shape, performance, or even future prospects. Coming to the future work, this analysis can be more expanded by integrate additional data sources like injury records and match statistics for a comprehensive player performance. Develop advanced predictive models using machine learning techniques to forecast players' future potentials. Implement clustering algorithms to group players based on similarities, helping talent identification and recruitment. Create by creating an interactive visualization tools for dynamic exploration of player data and facilitating deeper analysis and insights. Thank you.